In this video, we'll discuss Bertrand's duopoly or Bertrand's competition in several forms. We'll be discussing its basic version, complementary goods version, differentiated goods version, matching price guarantee, and sequential move version. Now we'll start with the basic version. In the basic version, we have two firms, firm 1 and 2, and they simultaneously set prices Pi, which is greater than or equal to 0. And the basic version, they sell identical goods and all consumers buy from the firm setting the lowest price. And in case of a tie, the demand is split evenly. Now both the firms, they have marginal cost of 10 rupees. Now the demand function for firm 1, it can be expressed as this function Q1. If price of firm 1 is greater than price of firm 2, then the demand for its product will be simply 0. If P1 is less than P2, then entire demand, it goes to this firm 1 and is given by 100 minus P1. And if there is a tie, when both the price match, say P, then in that case, the demand is split evenly and it is given by 1 by 2, 100 minus P. Now in this case, we need to show that there is a unique Nash equilibrium and it is at 10, 10. Now what we'll say is, let the lower price be PL and higher price be PH. Now we'll discuss several cases. Case 1, when PL is less than 10. Now if PL is less than 10, then in that case, the firm having the lower price will take up the entire demand, but the firm will make a loss since the marginal cost is 10. So this firm, it can do better with higher PL greater than or equal to 10. So this case, it cannot be a Nash equilibrium. Now if we consider the second case, when PL is greater than or equal to 100. Now if PL is greater than or equal to 100, then in that case, quantity will be less than or equal to 0. So there will be no sales. So the firm can do better by reducing the price. So this is also not a Nash equilibrium. Now this third case, when PL, it lies between 10 and 100. Now if PL is less than PH, it is not an equilibrium because this firm which is quoting the higher price would want to gain the market share by reducing the price. So both the firms, they'll keep undercutting. So this also is not a Nash equilibrium. Now this fourth case is when PL, it is equal to 10. Now if PL is equal to 10, then PL, it is less than PH. It is not a Nash equilibrium because in this case, this firm, it will have incentive to increase its price to make a profit. So the only candidate left is when PL equals PH equals 10. So the unique Nash equilibrium of this game is when both the firms, they set the price which is equal to their marginal cost. So in this case, P1 is equal to P2, it is equal to P and it is 10. And for this case, Q1 will be equal to Q2 and will be equal to 1 by 2, 100 minus 10. So that will be simply 45. So at this Nash equilibrium, if either firm raises its price, it would sell 0 quantity, and if it lowers its price, then it will make a loss. So the best response of both the firms is at 10, and this is the unique Nash equilibrium for Bertrand competition with the identical goods in the basic version. Now we'll consider Bertrand's competition with differentiated goods. Now in this case, demand for each product, it is given by Q1, which is 100 minus 2P1 plus P2, and Q2, which is 100 minus 2P2 plus P1. And in this case also, marginal cost is 10. Now in this case, coefficient of P1 is negative and coefficient of P2 is positive, which means if firm 1 raises its price, its demand is going to decrease. But at the same time, if firm 2 raises its price, then the demand for this product 1, it will increase. So in this case, these products are substitutes. Now we need to find Nash equilibrium for this game. Now for this, what we'll do is we'll write profit function for this first form, and we can write this as pi 1. It'll be given by, now price of good is P1 and marginal cost is 10. So profit will be P1 minus 10 into Q1, which we can write P1 minus 10 into 100 minus 2P1 plus P2. Now we can write this as 100 P1 minus 2 P1 square plus P1 P2 minus 1000 plus 20 P1 minus 10 P2, or we can write this profit function as pi1 equals minus 2 P1 square plus 120 P1 plus P1 P2 minus 10 P2 minus 1000. Now aim of this firm 1 is to maximize its profit. So what we'll do is we'll write d pi 1 by dp1. So it'll be minus 4 P1 plus 120 and plus P2, and it must be equal to 0. And if we find second derivative, del square pi 1 upon del P1 square, it is minus 4, which is less than 0. So second derivative negative, it means it's a point of local maxima. So from this we can write P1 as 120 plus P2 upon 4. So best response of this firm 1 to the price P2 of second firm will be given by 120 plus P2 upon 4. And the same way we can write profit function for second firm, and will be given by P2 minus 10 into Q2, and will be P2 minus 10 into 100 minus 2 P2 plus P1. Now solving this, we'll get profit for the second firm as minus 2 P2 square plus 120 P2 plus P1 P2 minus 10 P1 minus 1000. Now again, if we differentiate this with respect to P2, we can write this as 4 P2 plus 120 plus P1, and it is equal to 0. And again, its second derivative will be less than 0. So from here we can get best response for this firm 2. So P2, when firm 1 sets the price P1, will be given by 120 plus P1 by 4. Now basically these are two equations and two unknowns. We can use algebra to solve them. So one way of solving it is, we can write this as 4P1 minus P2. It is 120, and this is 4P2 minus P1, and it is 120. Now we subtract second from first. We can write P1 equals P2, and if we put P1 equals P2, we'll get P1 equals P2, and this is 120 by 3, and will be equal to 40. We could have solved this question using symmetry also. Since both the firms have similar functions, straight away what we could have done is, we could have taken P1 equals P2 equals P, and here if we put this, we can write P equals 120 plus P upon 4, or 3P equals 120, that is value of P is 40. So next equivalent for this game will be at 40-40. When both the firms, they set the same price and they set the price 40. Now if they set the price 40, in that case value of P is 40, and Q1 will be equal to Q2, and will be equal to 100 minus 2 into 40 plus 40, and there will be 60. So both the firms, they'll set the price 40, they'll sell the quantity 60, and they'll make the profit pi 1 equals pi 2, and there'll be 60, and there'll be 40 minus 10, 30 into 60, and there'll be 1800. Now we look at complementary goods version of Bertrand's competition. Now in this case, the goods are partial complements such as phones and headsets. Their demands are given by Q1 equals 100 minus 2P1 minus P2, and Q2 is 100 minus 2P2 minus P1. So again, there is a symmetry in the problem. Now in this case, quantity of firm 1, it increases when it reduces its price, or when firm 2 also reduces its price, since both the coefficients they are negative. So in this case, both the products, they are complementary. And for this example also, marginal costs are 10 per unit. Now here also we need to find its Nash equilibrium. Now we let profit function for firm 1 will be given by pi 1 and will be P1 minus 10 into Q1, which is P1 minus 10 and will be 100 minus 2 P1 minus P2. Now we can write this 100 P1 minus 2 P1 square minus P1 P2 minus 1000 plus 20 P1 plus 10 P2, or pi 1 is 120 P1 minus 2 P1 square minus P1 P2 plus 10 P2 minus 1000. Now again, our aim is to maximize this profit. So we'll differentiate with respect to P1. So it will be 120 minus 4 P1 minus P2 and it will be equal to 0. Now from this we can write best response for firm 1 for the price of second firm will be 120 minus P2 upon 4. Now since there is a symmetry in the problem, we know that Nash equilibrium will have P1 equals P2 and AB equal to P. Now we can write this as P equals 120 minus P upon 4, or 5P equals 120. Value of P is 24. So in case of complementary goods, both the firms, they'll set up the price P1 equals P2 equals 24. So in this case, Nash equilibrium will be at 24, 24, and they'll sell the quantity Q1 equals Q2 and it will be equal to 100 minus 2 into 24 and minus 24, which is 28, and they'll make the profit pi 1 equals pi 2 and it will be 24 minus 10, 14 into 28, which is 392. Now another version of Bertrand's competition is with price matching guarantees. Now we look at this basic version in which both the firms they adopt price matching guarantees. Then in that case we need to find its Nash equilibrium. Now in this case, when both the firms they set up the same price, then demand for each firm it is given by Q1 equals Q2 and will be 1 by 2 and 100 minus P, where P1 and P2 they are both P. Now if we write profit function for first firm, it will be P minus 10 into 1 by 2 100 minus P. So it will be 1 by 2 and then it will be 100P minus P square minus 1000 plus 10P, or this pi 1 will be 1 by 2 110P minus P square minus 1000. Now we differentiate with respect to P, we'll get this as 1 by 2 and will be 110 minus 2P and will be equal to 0. Now in this case, P1 equals P2 equals P and it will be given by 110 by 2, which is nothing but 55. So in case of matching price guarantee in basic version, Nash equilibrium will be at 55, 55. Now this price, they'll both sell the quantities Q1 equals Q2 and it will be 100 minus 55 by 2, which is 45 by 2, and they'll each make the profit pi 1 equals pi 2. Now this is 55 minus 10, 45, and it will be 45 into 45 by 2, which is 2025 by 2. Now another version of Bertrand's duopoly is with sequential moves. Now the sequential moves game, it can have either complements version or substitute version. Now in this case we are discussing complements version. Now here again we have Bertrand's duopoly model with goods being partial complements. So their quantities they are given by 100 minus 2P1 minus P2 and Q2 is 100 minus 2P2 minus P1 with marginal cost of 10. And their profits are Pi minus 10 into Qi. Now in this version we have to find Nash equilibrium if firm 1 moving first and firm 2 moving second. So now it becomes a sequential move game. So what we'll do is we'll write profit function for firm 1. So this pi 1 will be given by P1 minus 10 into Q1, which is P1 minus 10 into 100 minus 2P1 minus P2. And we'll also write profit function for second firm. Now profit function for second firm is P2 minus 10 into Q2, which is P2 minus 10 into 100 minus 2P2 minus P1. Now since firm 2, it moves second, it will respond to the price set by firm 1. So what we'll do is, in this case, we'll determine firm 2's best response. For this, we'll first simplify this profit function pi 2 will be 100P2 minus 2P2 square minus P1P2 minus 1000 plus 20P2 plus 10P1. So it will be this pi 2 and then minus 2P2 square plus 120P2 minus P1P2 plus 10P1 minus 1000. Now we need to maximize profit for firm 2 for the price set by firm 1. So what we'll do is we'll find del pi 2 upon del P2 and it will be minus 4P2 plus 120 minus P1 and it will be equal to 0. Now from this we can write best response of firm 2 to the price P1 as 120 minus P1 by 4. Now this is the best response of firm 2. Now firm 1, being the first mover, already knows for any value of P1, the response of P2 will be 120 minus P1 by 4. So having this knowledge, this firm 1 will try to maximize its profit. So in order to determine optimal price for firm 1, we'll write its profit function pi 1 and it will be P1 minus 10 and this is 100 minus 2P1 and minus, now this P2 will be given by this best response of firm 2, which is 120 minus P1 by 4. Now this is P1 minus 10 and here will be 400 minus 120 and that will be 280 minus, now this is 8 and plus 1, so it will be minus 7P1 divided by 4. So we can write this as minus 7P1 square plus 280P1 plus 70P1 minus 2800 divided by 4, or this pi 1 will be minus 7P1 square plus 350P1 minus 2800 whole divided by 4. Now firm 1 is going to maximize its profit. So it will be del pi 1 upon del P1 and it will be minus 14P1 plus 350 equals 0, or value of P1 is 350 by 14. And P2 will be 120 minus P1 by 4 and will be 120 minus 25 by 4, which is 95 by 4. Now if you will recall, in simultaneous move version, equilibrium, it was at 24,24, whereas in sequential move game, the equilibrium has shifted to 25,23.75. So clearly, in sequential game, this firm 1 has an advantage. Now we consider sequential Bertrand competition with differentiated products. Again, demands are given by 100 minus 2p1 plus p2 and 100 minus 2p2 plus p1, and marginal cost is at 10, and the firm one, it moves first. Now again we write profit function for this first firm. It'll be p1 minus 10 into 100 minus 2p1 plus p2. For second firm, it'll be p2 minus 10 into 100 minus 2p2 plus p1. Now since firm 1 moves first, this firm 2 will respond to the price set by this first firm. So first we'll simplify this pi 2. It'll be 100 p2 minus 2p2 square plus p1 p2 minus 1000 plus 20 p2 minus 10 p1. We can write this as 120 p2 minus 2 p2 square plus p1 p2 minus 1000 minus 10 p1. Now we'll find best response for this firm 2. So we'll find del pi 2 upon del p2. So it'll be 120 minus 4 p2 plus p1 equals 0, or best response of firm 2 will be 120 plus p1 whole divided by 4. Now firm 1 is at advantage knowing that best response of firm 2 in any price set up by this firm 1 will be 120 plus p1 by 4. So firm 1 will maximize its profit knowing p2 is going to be 120 plus p1 by 4. So now we can write profit function for firm 1 as p1 minus 10 into 100 minus 2p1 plus 120 plus p1 by 4, and will be this pi 1, and we can write this as p1 minus 10. Now this is 400 plus 120, and there will be 520 minus 7p1 whole divided by 4. Now we simplify this, we can write this pi 1 as minus 7 p1 square. Now this is plus 520 plus 70 will be 590 p1 and minus 5200 whole divided by 4. Now firm 1 will maximize its profit. So we can write minus 14 p1 plus 590 equals 0. So in this case, this p1 will be 295 by 7, and we can write p2 as 1135 divided by 28. So this is the equivalent in case of sequential move gain.